Nearly 5 years have passed since we detected the mysterious interstellar object Oumuamua, and in that time, this object has covered a colossal amount of distance, over 4.5 billion kilometers, or beyond the orbit of Neptune by this time. By way of comparison, it took nearly a dozen years for Voyager 2 to cover the same distance, and this, of course, is one of the reasons that we were able to identify this object as being interstellar in nature. Its sheer velocity and the fact that it was traveling at solar system escape velocity indicated to us that it had to have come from outside. Plus, its unusual trajectory, that gave it away as well. And even so, we didn't spot this thing until it was beyond the orbit of our own planet. That alone, however, was the least mysterious thing about this object. As a matter of fact, there are so many unusual characteristics to Oumuamua that there are scientists beginning to talk about a highly ambitious mission that won't be able to intercept Oumuamua until our century is more than halfway gone. And yet, the advocates for this ambitious intercept mission make a very, very clear case that this is an opportunity that we simply cannot pass up. Oumuamua has defied all explanation. All natural explanations for this object and its strange characteristics and behavior have fallen flat. There are some explanations that seem a little bit more likely than others, but all of them have significant problems. Except for one, that Oumuamua is a piece of alien technology. But one thing is clear, regardless of what Oumuamua actually is, it is unique, unlike anything we have ever observed. And if that's not a reason to undertake an ambitious mission to intercept it, I don't know what is. But how the hell are we going to accomplish this? And what is it about Oumuamua that makes it so special? Well, we're going to find all of that out in just a moment. Someday, when you have nothing better to do, go ahead and pull up Oumuamua in your search engine and then look for images, and you are more than likely going to see something like this, an elongated cigar-like object, which is what we initially thought that Oumuamua might look like. However, we know for a fact that it looks nothing like this. It looks more like a flattened pancake-shaped object, even if it is some kind of asteroid. It doesn't look like this, and it doesn't look like that, and it doesn't look like this, nor does it look like this, nor does it look like, oh, well, you get the idea. Geez, it certainly doesn't look like that, and it doesn't look like that either. Really, why the hell is nobody showing Oumuamua as it actually is? And once again, I'm not talking about the people who think it's a light sail. I'm talking about people who think that it's a nitrogen iceberg or perhaps a hydrogen iceberg. Everything that we have observed about this object clearly indicates that it is extremely flat, unnaturally flat, elongated, and more like a pancake than a cigar. And yet, image after image, time after time, we get an inaccurate view of what we think Oumuamua looks like. And by the way, this illustration is the only illustration that has any kind of resemblance to an asteroid that may have the same kinds of characteristics that Oumuamua does. This was created years ago, and yet it doesn't seem to get duplicated by much of anybody else. And if it's a light sail, this again is the only illustration that has been put out to demonstrate what it might look like if Oumuamua is indeed a piece of alien technology. Other than that, you just get cigar after cigar across the entire spectrum of the mainstream media up to the present day, which is utterly absurd and unscientific, but that's the least of the problems that we've encountered while analyzing this mysterious interstellar visitor. The first bizarre thing about Oumuamua is the speed that it happened to be traveling at when it came under the influence of our sun's gravitational force. It was traveling at about the speed of what's called LSR, or local standard of rest. That means that its position was essentially stationary relative to the sun and every other object that's orbiting the Milky Way's core. Now, the odds of something like that happening are 0.2%, not 2%, but 0.2%. Now, this simply could have happened by chance, but it's so incredibly useful if this were, for example, a navigational beacon, that this is our first indication that it might have been there by design, but certainly still not enough evidence on its own. But the more we studied this object, the more mysterious it became. For example, its albedo was unusually high, very unlike any conventional asteroid, perhaps somewhat similar to a comet, but certainly a lot more similar to the kind of reflectivity that we observe with metallic objects. Now, there are metallic asteroids that might explain something like Oumuamua, but still, its reflectivity was so unusual to categorize it as perhaps a 1 in 100 object at best. So we have an object that had a 0.2% chance of traveling at the speed that it was traveling when it came into contact with our sun, and it was also unlike 99% of the natural asteroids that we've observed. And it got even stranger. For example, the asteroid was tumbling. Now, this isn't completely unusual, but the rate of tumbling was very steady and very consistent, which wouldn't be unusual in itself, but it proved to be unusual in conjunction with another unusual behavior of Oumuamua, and that is the fact that it started to accelerate at a speed of 17 meters per second faster than it should have while it was on its way out of the solar system. Now, this initially was attributed to cometary outgassing. However, this object was under very close observation by telescopes designed to detect cometary outgassing, or any other kind of outgassing for that matter, and it detected absolutely nothing. So after that, mainstream scientists really started grasping at straws, trying to imagine an asteroid that would be comprised of some sort of material that could theoretically be involved in an outgassing process that couldn't be picked up by the telescopes. Nitrogen was one example, hydrogen was another example. However, both of those explanations also fell flat because of the tumbling. Any sort of outgassing that would have accounted for this much of a shift in velocity also would have changed the object's tumbling rate. So much so, actually, that an object comprised out of nitrogen or hydrogen would have been ripped apart, and yet it wasn't. And this isn't the only problem with the nitrogen iceberg or hydrogen iceberg theory. It was also determined that the rigors of interstellar space, all of the interstellar cosmic rays and radiation, would have eventually broken down something as fragile as a nitrogen iceberg, assuming that something like that could even exist. Now, granted, there are reasons to believe that something like that could exist. For example, a shard of of Pluto, could be flying around the solar system if it were driven away from the planet by a meteor impact of some kind. We haven't seen anything like that, but there's every reason to believe that something like that exists. But once it came within less than 0.2 astronomical units of our sun, something with a boiling point as low as nitrogen probably would have been utterly destroyed by our sun, let alone the rigors of interstellar travel, as I was just talking about. So in the end, after the media announced that the composition and origin of Oumuamua had been identified as a nitrogen iceberg, afterwards Avi Loeb and his colleagues dismissed the whole concept and debunked it. And then, of course, when his claims were challenged, two other scientific teams supported his point of view. Oumuamua is not a comet. It is not an asteroid. It's not some sort of bizarre asteroid comprised of nitrogen or hydrogen. We don't know what the hell it is. But what we do know is if it is a light sail, its deviation, its unusual acceleration can be elegantly explained by a light sail approximately 100 meters in diameter and only a few millimeters thick. If Oumuamua's acceleration is to be attributed to solar radiation alone, and we have observed nothing else that could possibly explain its unusual deviation, its unusual velocity, then it has to be this thin and it has to be roughly this size. Now, if indeed it is an extraterrestrial light sail, that of course is a huge reason to try to track it down. And up to this point, in spite of years and years of analysis, in spite of so many theories to try to explain Oumuamua's bizarre behavior, every natural explanation has fallen flat, which means that if it is a natural object, it's a natural object unlike anything else that we have ever observed, radically unlike anything else. And once again, that is ample reason to chase this thing down. But it's already heading out of the solar system faster than Voyager 2. How the hell can we possibly catch it? Well, it is actually possible. In 2019, utilizing software called the Optimum Interplanetary Trajectory Software, or OITS, developed by Adam Hibbard. By the way, his YouTube channel and other channels are linked in the description. Please pay him a visit. An organization called Project Lyra developed a mission to intercept Oumuamua utilizing existing technology without having to devise a new type of spacecraft to do so, because that would take entirely too long. This spacecraft would be largely based on the Parker Solar Probe, and by the way, you can see that heat shield there designed for close approach to the sun. Why is that necessary? Well, get ready to have your mind blown, because this mission configuration is truly unique. Now, various mission configurations also use different types of technology like tiny light sails, which would be quite ironic to have our own light sails pursue an alien light sail, and also possibly nuclear thermal propulsion. However, using our current day technology, here's the plan. First of all, to launch the probe utilizing a Falcon Heavy or perhaps SLS. Finally, let's find a really good use for that rocket aside from lunar missions. So the probe loops back, heading for Earth. I think you get the idea right now, preparing for a flyby to increase its velocity, and on it goes to Jupiter. However, this is where things get really strange. It slingshots around Jupiter, increasing its velocity even further, and heads back towards the sun. Why does this make any sense? Well, because it's going to be picking up a hell of a lot more velocity as it passes the sun at a tremendous rate of speed, fast enough to intercept Oumuamua. And even at this vast velocity, it will take many, many decades before it finally overtakes Oumuamua, intercepting sometime in the early 2050s. Of course, that date gets later and later the more we put this off. However, this mission has one vital Achilles heel. We may not know exactly where Oumuamua is because this object is not traveling according to the laws of gravity. A fleet of light sails sent out to a variety of different potential intercept points might actually make more sense because, as I said before, this thing deviated by over 100,000 kilometers by the time it reached the orbit of Jupiter. How far out of position might it be now? If it is indeed some kind of bizarre cometary outgassing that caused this deviation, this odd acceleration, then it shouldn't have experienced this anymore that far away from the sun. However, if it was a piece of alien technology utilizing solar radiation to accelerate, that means that Oumuamua, even at that distance, is going to deviate considerably as the years pass, even from solar radiation at such a colossal distance. It may prove to be tens of thousands, hundreds of thousands, or even millions of kilometers out of position from where we think it's going to be if we're counting on gravitational influence alone and where we project it's going to be because of that. That is a very, very serious problem. There are potential solutions to this problem, but it's really going to depend on what the Project Lyra planners decide to do and who they choose to believe. One possibility would be to put very good detection instrumentation, perhaps a small telescope, on the craft as it approaches its projected intercept point. If it does indeed determine that Oumuamua is out of position, it may be able to adjust its course. However, that would be very difficult and require some pretty powerful engines to deviate from such a vast amount of delta V. Another option would be to send two probes, one out to where gravity should be putting Oumuamua, and the other location where solar radiation pushing on a light sail should put Oumuamua, if indeed it is what we think it might be. Now, personally, I think that that's not going to happen. I think that Project Lyra, under the influence of the scientific majority, is most probably going to be heading towards where gravitational influence and conventional science says that Oumuamua must be because of the influence of the sun and surrounding stellar bodies. However, if Oumuamua is a piece of alien technology traveling at a different velocity, it will be a completely wasted mission. We dare not take that risk, and yet I'm sad to say that that may indeed be possible. And this is what Alien Week is all about. I believe that we absolutely need to have a sober and sensitive approach to the possible existence of civilizations beyond our own. When we catch sight of something that defies all natural explanation, or at least makes a natural explanation seem extremely unlikely, then we need to absolutely consider the possibility that it may be something else, that it may be the product of another civilization. We need to be free to discuss this possibility without ridicule, without having our careers destroyed, without sabotaging any of our future plans to get grant money from the government and respected scientific institutions. But that is not the current scientific environment. Only astronomers like Avi Loeb and his colleagues, who appear to have the support of Harvard University and their vast amount of funds, seem to have the freedom to speak the way they want to about this subject. The rest of the scientific community must either adhere adhere to natural explanations and to conventional wisdom or remain silent. And it is this narrow-minded scientific environment that makes me the angriest of all. It makes me angrier than anything Jeff Bezos does. It makes me angrier than SLS, Boeing, anything, simply because we cannot have this kind of scientific environment if we want to excel, if we want to discover new things in the cosmos, and most importantly, if we want to find civilizations and intelligence beyond our own, which would be the greatest scientific discovery of all time. And with each passing day, the most promising candidate for a piece of alien technology, or at the very least, a natural object that defies description, that is different from anything we have ever observed before, is slowly slipping away from us. We can still change this, we can still overtake it, but somebody needs to pick up the torch and lead the charge. Please like, please subscribe. Also, please check out my other videos in this series. Don't miss any more of Alien Week. And as always, stay angry about space.